In this video, we will teach you how to solve the percentage yield. The percentage yield of products is found by this formula that we have here. So it's equals to the percentage yield is equals to the actual yield. The actual yield will be given to you, and the theoretical yield times 100. To understand this example better, we need to use it in an example. Let's say that we have an example given in the form of a reaction. So it's 2P plus 3Cl2 that makes 2PCl3. This is a reaction given to us, and these are the other information that will be given to us. So the information we have, the mass P is equal to 12 grams, Cl2 is 35 grams, and the actual yield is given as 42.4 grams. And then in this case we can see that the molar mass of P is equal to 30.97 grams per mole, and the molar mass for Cl2 is equal to 70.9 grams per mole. And then using this formula we will try to find some, we'll go step by step trying to find a mole of each product, and then we will try to solve it to the percentage yield. So first we need to find the mole of P. So the mole of P is equal to mass divided by molar mass. In this case it's going to be NP is equal to, so the mass of the P is given, which is in here, 12 grams. So 12 grams divided by, and the molar mass is given in here. So this is going to be 30.97 grams per mole. And the answer for this would be, if you use a calculator, obviously you will get 0.387 mole. So we found that the mole of P is equal to this much. We're just gonna highlight this real quick so we don't forget. And then using the next formula, we have to use the same formula for chlorine. In this case this is going to be chlorine. So N of Cl2 is equal to the mass. So we're not going to use the formula, just put the values in. So for the mass we have 35 grams in here, so it's going to be 35 grams divided by the molar mass of chlorine, not chlorine, Cl2, so it's going to be dichloride, I guess. I don't know the actual name of the compound, so we're just going to use it as 70.9 gram per mole. If we use a calculator we're gonna get 0.494 mole. So the mole of Cl2 is equal to this much. Now we're gonna highlight this so we don't forget. Now we have found that the moles of each of our product, and then we use one of these formula. So we're gonna use this formula, which is the mole of P is equal to mole of Cl2 each divided by their coefficient. So we can see that their coefficient are in the formula. So that coefficient of P, is it's 2, and the coefficient of Cl2 is 3. You can see it in here. So the coefficient for this would be 3, and the coefficient for this would be 2. Now we have reached this formula. We can use it to find the, what is it called, to find the limiting reagent. So in this case we just use mole of P is equal to N of Cl2. So instead of Cl2 we're just going to use its mole. So and the mole of Cl2 is here, which is going to be 0.494 moles, and then divided by its coefficient. So 0.494, and then this bracket close, and then divided by the coefficient, which is 3. Because we're using n and here, and then we're gonna move this hit this in here, so this is going to be times 2. So times 2. Now if we put this in the calculator, we'll find that the mole of P will be 0.329. We can see that 0.329 is very close to 0.387, so we cannot trust this to be the limiting reagent. To make sure, we can use another formula, the same formula, but in this case we're just gonna put P instead of Cl2. So N of Cl2 is equals to N of P, each divided by their coefficient, and then instead of Cl2 we're just going to use N of P. So N of Cl2 itself is equals to N of P. N of P was what? The molar of P. So this is going to be the mole for the P, 0.387. 0.387 divided by its coefficient, which is 2, and then times this number times 3. So if we put this in the calculator, we will be getting 0.581 moles. To see which one is the limiting reagent, we can see that this number that we have gotten here is pretty much, it's very different from this number that we have. So in this case we will need to have this much mole of Cl2 to make the reaction completely react with P. So in this case we don't have enough of that, which we have 0.494. So in this case Cl2 will be our limiting reagent. Because how did you find it? This is because we have calculated the moles in here, and then we can compare this mole that we found with this one, and these two numbers are not very similar, so we can say that they are not. We can say that Cl2 will be our limited reagent. If you're wondering why we're not using N of P, so let's say that N of P is found in here, which is 0.329, and if we compare this to this one, compared to this, these two numbers are very much similar. So we found that Cl2 will be our limiting reagent. Next thing, once we have found the limiting reagent, we're going to use the theoretical yield. So N of the product, which is what, if you look at the formula, N of the product is equals to N of the P Cl3 is equals to N of our limiting reagent. So N in this case is Cl2. So these two divided by their coefficient, we can see that their coefficient are in the formula. So the coefficient for Cl2 is 3 and for P is 2. So for P is 2 and then is 3. Now we're going to use this formula to find the mole of PCl3. N of PCl3 is equals to N of Cl2. N of Cl2 is what? N of Cl2 that we have found is 0.494. 0.494 divided by its coefficient, which we have 3, and then multiply by this number that we have here, so 2. If we use a calculator to find this, we're gonna get 0.329 moles. Now we have found the mole of this number, of this product that we are trying to find. So the N, the product, the molar, excuse me, I'm so sorry about it. The mole of PCl3 is equal to this number, 0.329. 93.29 moles. Now we will be converting this number mole into grams. So for that we can use this formula. So N is equals to 0.329 moles, and then the mass is equals to, we don't know, we're trying to find this, so exclamation mark, and then the molar mass is equals to, if you're trying to find the molar mass of thing, you can look at the you can look through the periodic table and then combine those terms to find the molar mass. In this case, this is going to be 137.32 grams per mole. Now, if you guys remember that we will be using this formula to find it. So N of, this is the mole mass, and then this is the molar mass. This is the general formula, but in this case we're trying to find the mass, so we're going to use this formula. M is equals to moles times molar mass. In this case, our M, which is the mass, is unknown, and then the molar mass that we have is 0.329 moles times the molar mass, which is 137.32 grams per mole. Now we have this formula. If you use a calculator, the mass will be 45.17 grams. 17 grams. This is the what is it called? So this will be the if you guys remember the formula, this will be we'll be using this formula, and then the theoretical for my days, the theoretical will be that number, so will be this number. Now we can use the formula for the percentage yield to find that percentage yield is equal to the actual yield, which was given to you in the beginning, the actual yield in here. So 42.4 grams is going to be 42.4 grams divided by the theoretical yield. So that's going to be 45 times 0.17 grams times 100. So this was the general formula. Now if you use a calculator, the percentage yield, my days, yield is equal to, if you divide this number by this number and then multiply that result by 100, you will get a 93.851%. So make sure to add the percentage symbol in here to represent that we will have 93.851% of the